Welcome to
Hey, everybody.
the Crypto Mining Tools podcast. And today we have Rob as our guest and Ethan, our co-host.
Hi, everyone.
Rob, why don't you tell us a little bit about who you are and what you're up to?
Awesome. Well, thanks, Scott. Thanks, Ethan. First of all, let me just say happy holidays to everybody. I hope everyone's having a great holiday season and getting a chance to take a break from the crazy world that is cryptocurrency. My name is Rob Walther, and I've been in IT infrastructure and operations for about 25 years. I've been building data centers and running IT operations all over the world. And I was director of global operations for Fidelity Investments for about 5 years. And while I was at Fidelity, I went to a lunch and learn, and they had a little expose on Bitcoin mining. And Fidelity, as you may know, is doing quite a bit with Bitcoin and Bitcoin mining. And being in IT, as they explain the technology and the blockchain and everything behind it, I immediately became just enthralled. I left that meeting just really wanting to learn more, and I started researching and learning everything I could about it, and started networking in the area in Raleigh, North Carolina, where I was living at the time. And I met some really great people in the space that were also just as excited about the technology as I was. Started working with JP Barrick at Mining Store, and we did some fantastic things together, building some data centers and hosting for mining equipment all over the country. And they're still doing some phenomenal things. Very excited about what they're bringing to the community. And then a couple months ago, and for the past year or so, I've been doing some research on liquid immersion cooling. Became very interested in that and the future possibilities that brings to the mining and efficiencies. And so that's kind of a little history of how I got to where I am today. Just really excited about the future of cryptocurrency and mining and supporting it in any way that I can.
Tell us what have you learned about immersion systems? Because I'm always fascinated by immersion technology, and I do believe it is the future of mining.
Yeah, absolutely. So liquid immersion cooling, and this is really what I hope to get most across today in this podcast is an explanation of all the research that I've done and try to boil it down, no pun intended, to some easy digestible information. So liquid immersion it comes in a couple different types. There's single phase liquid immersion. Mm-hmm. There's two-phase liquid immersion, and there's indirect liquid immersion. So those three types, single phase.
Tell us the different types. This is very interesting.
Yeah, so single phase, basically the computers and the servers are completely immersed in a non-conductive liquid. While these machines are in the liquid, you can actually put your hands in the liquid and you won't get shocked or electrocuted. All right, so they're completely non-conductive. And single phase, basically the heat from the chips and the computers goes into the fluid directly. And then as the hot fluid rises to the top of the immersion tanks, that fluid then goes to a heat exchanger where the heat is removed and then transferred to either directly into air or to another fluid potentially. And then that same fluid then comes back into the bottom of the tank and completes the cycle all over again.
Okay, so it goes from the bottom to the top of the tank?
Correct.
Fluid? Okay.
Natural convection takes the heat to the top. And they call it single phase because the fluid actually doesn't change phase. It doesn't evaporate. It just heats up. Okay. So these fluids have a high boiling point. So they don't actually boil. They just take the heat. And then that heat is then gone through a heat exchanger and removed. And then that cooler fluid comes back in.
What about fire? Is this fluid flammable at all? Is it? Yeah, it just seems so unnatural to see electronics immersed.
It
Like,
does. It's really counterintuitive, isn't it?
yeah.
You know, the fluids that I've been using, and there's a couple different types of fluids that I'll explain here in a minute, but it's very important to make sure that the fluids you're using have high flash points, have high burn points.
Okay,
You
so
can eliminate the risk of fire.
okay, so
And
tell
many
us.
of these have very, very high flash points.
Yeah, tell us about the dual phase. So you told us about
Yeah.
single phase. So tell us about the dual phase.
Absolutely. So dual phase or two phase is exactly what it says. So the fluid actually changes phase. So it goes from a liquid to a gas,
To a gas.
and it actually has a low boiling point. So as the heat from the chips goes into the fluid boils, and
Okay.
that change of phase is a great way to remove that heat. Now, as that gas and vapor from the boiling of that liquid goes to the top of the tank, it brings the heat with it.
Sure.
And in these two-phase liquid immersion tanks, what you'll commonly find, is a heat exchanger right above the fluid. And
Okay.
as that gas and vapor interacts with the heat exchanger, it recondenses and drips right back down into the container, into the tank. So
So
it's two
I'm
phase.
imagining something like a still, right? So you have the fluid at the bottom, and then it evaporates up through some condenser coils, and then comes down. So something similar to that.
Yeah, it actually doesn't go into the coils. It condenses on the surface of the coils and then drips
Mhm.
back down.
Okay.
So what's nice about two-phase is that that fluid in the tank stays in the tank, essentially. It doesn't need to get piped out to a separate
To
heat.
exchange the heat. Okay.
It stays self-contained. Now, some of the potential problems with two-phase is that some of the fluid can evaporate completely out of the tank.
Mhm.
Now it does tend to stay. The vapor does tend to stay right above the fluid, but you have to have sealed tanks to some extent to prevent loss from just evaporation, and so it's a little trickier, but it's also very efficient. And then the fluid in the heat exchanger above the tank fluid is usually water or some cooler based fluid that makes sure that it hits the saturation point so that vapor recondenses and drips back down into the tank.
Wow. So, yeah, it sounds like a much more complicated system. So, tell us about now. There's also a three-phase system.
Well, there's what's called indirect cooling. So a
Okay,
lot of you
indirect.
a lot of you may have heard of like water cooled
Mm-hmm.
systems, and basically it's the machines aren't necessarily immersed
Mm-hmm.
in water, right? Because that's conductive, so that would not be good. But the water is brought directly to the chip and plate in contained, however, so it doesn't leak out. But it removes the fluid right into the water, which is right next to the chip in a contained chamber, and then that fluid then gets ejected out and cooled and then brought back in. But those are very specific, require a lot of treatment specific to the boards to make sure the water doesn't leak out actually and get on the electronics equipment. So it's called indirect.
Okay.
So, Rob, why don't you tell us a little bit about how this relates to cryptocurrency mining and how you're using or planning to use immersion?
Yeah, sure. So one of the great things about liquid immersion is that it is known to be more efficient than air cooling systems. Now, there's a lot of statistics around how much more efficient is liquid immersion. I've heard anywhere from 10% to 40%. And it really depends on what sort of air-cooled data center you're comparing liquid immersion to. There are some air-cooled data centers that, like in cryptocurrency, in many cases, where there's no chillers, no air conditioners, it's purely just outside ambient air, which is more efficient, right, than your traditional data center with a very expensive crack unit or air conditioner unit. But it still is more efficient. And what's great about liquid immersion for cryptocurrency is that you can remove the fans entirely from the machines themselves. So the machines don't have to spend all that power to run fan, cool them, right? So a lot of times when I'm putting cryptocurrency miners in this liquid immersion cooling systems, I'll just take the fans off completely, and that can save anywhere from 5 to 30% depending on how many fans or what types of fans are on the equipment.
Mm-hmm.
So more efficient. Other benefits are like a lot less noisy, and it's able to run equipment in hot and humid climates. So we can keep machines running here in Texas, where I'm at, in the middle of the summer, in liquid immersion cooling, and also in colder climates. We don't have to worry about hot air recirculation back into a data center unit, because the liquid immersion keeps it at a consistent temperature and is able to do that in both hot and cold climates. So there's benefits in running it in both environments. It's also eliminating dust and airborne contaminants and humidity from running through these machines, which can be very destructive and corrosive to the equipment. I'm sure many people in the cryptocurrency industry, mining industry, have seen dirty machines,
Mm-hmm.
And that's just not part of the liquid immersion world. These machines stay running, stay clean, stay consistent, and use less power and create less noise. So it's just so much better overall, and it's a technology that is going to, I think, really start to take off here as it becomes more affordable, which has been a challenge for liquid immersion.
So I'm really glad that you mentioned affordability, because I think that's been the largest hurdle for anyone to get involved. What are you doing to help with those challenges, to make it more affordable, to make it easier for people to get into it?
Yeah, so that is really one of my main objectives with what I'm trying to do here is what can we do to not necessarily reinvent the wheel. Liquid immersion has been around for a long time. It's very well proven technology, but what can we do to optimize it, make it more efficient, take this bread box and make it just a little bit better of a bread box, right?
Mm-hmm.
So there's a couple ways that, based on my 25 years of experience in IT infrastructure and operations, so I'm bringing into that some ingenuity, some innovation that will make it more cost effective. For example, a lot of liquid immersion systems require an external dry cooler, where the single phase fluid leaves the tank and goes out to this external dry cooler system. It's chilled and then brought back into the tank. Well, that's a lot of plumbing. That heat exchanger outside the unit can be very expensive. A lot of pumping and moving parts. So what I've done with my modular data center design is I've actually integrated the heat exchanger directly into the module container itself.
Okay.
So that eliminates the amount of piping. The heat exchangers that I'm using are much more cost effective than the dry coolers, these big units that are outside. It makes the modular data center much more mobile because we don't have external pieces lying all around that have to be integrated. So it's very integrated, all built inside of this one container system. In addition to that, I've been bringing in a lot of innovation into the design of the tank, keeping it simple and not over-engineering it, and also working with the fluid providers to make sure we're getting the best cost possible on the fluids. And the other thing is maintenance. So it takes a lot of time and energy to maintain an air-cooled data center. Well, I've designed my liquid immersion systems to be completely remote controlled. Everything,
Wow.
every circuit, every breaker, every pump, every machine, every network port can be completely 100% monitored, maintained, stopped, and started from a remote location. It's all internet connected systems. So, and then one of the other things that I'd like to touch on here as well is, I think a lot of us are starting to see much more powerful mining machines coming on the market.
Yeah.
So we have machines like the M20, or I think are 3,200 or 3,600 watts. It's crazy. And these machines require a tremendous amount of power and heat removal, which liquid immersion is really becoming the way to go with these higher powered machines. And air cooling just really can't keep up with some of these higher powered machines, or I should say, in certain climate conditions, it can be very difficult for air-cooled systems to maintain some of these higher powered equipment, depending on airflow and the design and everything, right? So one thing that I've done with my design is each circuit is capable of supporting 4,000 watts.
Wow.
We can, and then with the liquid immersion cooling, we can help to make sure that heat is removed efficiently, and that equipment is run at a very safe, stable, supportable temperature in the long term to keep that machine running for years to come.
So at 4,000 watts, I mean, at that point, you're not really dealing with C13 or C19 connectors. Are you thinking about modifying how the miner actually connects to the power source at that point?
Yeah, that's a great question. So the C19 connectors, C20 connectors are still viable for that setup. The PDUs that I have actually with the 4,000 watts per circuit can support the C19, C20 connectors. So that's still possible. But I think as that really is pushing the limits, though, Scott, as we start to go even potentially above that. So they're going to have to start using new and different connectors, and the power supplies are definitely changing. There seems to be a movement towards 480 to 277 directly, as opposed to today, most of the power supplies can only go up to 250, 260. So there's starting to be some movement and change there as well.
That's fascinating. Yeah.
Yeah. One question I had, going back to maintenance. So I was wondering, if you put something in immersion, usually it's going to, it's going to break the warranty. It's going to void the warranty. So, and I know there's some mining manufacturers that are coming out with boards that are made for immersion, so that might be advantageous to work with a company like that. But for the most part, if you're buying the Bitmain or eBang or WhatsMiner, it's going to void the warranty. So are you thinking like you're going to be putting used miners in here or brand new miners, or what's your strategy for sourcing and using those types of miners?
Yeah, so there is concern around warranty for sure. Right now, we're just speccing out the S9s just to start with, and then the thing about voiding the warranty, the liquid immersion is capable of keeping these machines free of dust and free of corrosive materials and free of the problems that usually break machines. And so that you're going to end up finding that the machines just run better in liquid immersion cooling. Not to say that we wouldn't want to get the machine fixed if a component does break, but you're right, Scott. A lot of these manufacturers are starting to come out with boards and equipment that is specific to liquid immersion. And what's nice about that new equipment is that it can be even more dense than air-cooled systems, because you can really pack in a lot of equipment in a small amount of fluid and get a lot more density with that new equipment. So,
what we're finding is users are generally okay with putting their equipment in liquid immersion, even if it affects the warranty. A lot of these machines just have the a chance to run better in liquid immersion, so they're not so concerned about it. But we also are able to provide repair and maintenance services for anything that does break. So that's a way to mitigate that as well.
Mm-hmm.
That's awesome. I'd like to take this moment to give a shout out to our sponsor, NovaBlock. NovaBlock is a mining pool that opened up here in August 2019. And in 4 short months, they've managed to become with one of the top 15 pools in the world. And they believe that as hash rate is migrating from China towards North America, they want to be a part of that movement, and they want to give their clients transparency and educate them on the best pools that are out there. So if you guys have not tried NovaBlock, go ahead and give them a shot. I mean, they rock.
Yeah, absolutely. And so we're offering the opportunity right now for our users to go to the novablock.com website, and you can sign up in the top right-hand corner. And on their website, if you enter the invitation code OFFORD18, that's OFFORD18, you can get a permanent reduction in your pool fees down to 1.8%. And it also, if you have a lot larger amounts of hash power that you can throw at it, you could probably even get a little bit lower than at 1.8%. So yeah, thanks to our sponsor, NovaBlock. Everybody go check them out at novablock.com.
Awesome.
Yeah. So yeah, Rob, with these S9s, like, what are the pitfalls that you found? I mean, obviously you've overcome a lot of the challenges that immersion brings, and I really love the idea that everything is self-contained. Is that like a shipping container that you're talking about, or?
Yeah, right now we're building this into a high cube shipping container, both 20 and 40-foot models. So everything fits inside, and like I said, including the heat exchanger. There's each 40-foot container has 20 tanks and can support 920 S9s.
Each tank?
Each container.
Oh, okay, each container.
Modular data center is 920. Each tank can hold 46 S9s or 24 S17 type devices.
Okay.
Well, what are you making your tanks out of? What kind of material?
Stainless steel. And there's all different kinds of, you can use cold rolled steel, stainless steel, aluminum. There's some people that are using some plastic fiberglass type units as well. But right now we're looking at stainless to be the most cost effective and corrosive resistant, and providing the fewest particulates into the fluid. And that brings to mind maybe the different types of fluid I could talk about if you'd like. Sure, yeah. So with single phase, the main type of fluid there is dielectric. Synthetic dielectric is the preferred choice. Mineral oil is also possible for, you may have heard machines running in mineral oil.
Yeah.
With mineral oil, though, I'd be really careful because there's not as many controls around mineral oil is just simply a byproduct. It's a distillate of the petroleum process. And it's a petroleum byproduct that can contain sulfurs and corrosive materials and even carcinogenic stuff could be hazardous to employees. So when you're looking for a single phase fluid, I would look for something that's synthetic, that is made in a controlled process where all of the contaminants are removed, and it's a very homogeneous liquid. Also, mineral oil can be very viscous and can oxidize over time and change color and get dirty. Whereas synthetic dielectric fluids don't really oxidize, or they stay clear. They're odorless. They're also food grade. They're very
biodegradable. They're very environmental friendly. Mineral oil, depending on how it's made, can be the exact opposite. It can be very, very non-biodegradable and very environmentally friendly. So that's for single phase. For dual phase, the two phase, they use what's called a fluorinated fluid. And that's the type of fluid that I mentioned earlier that boils at a really low temperature. One thing about that is it can also be non-biodegradable, and it can also be, it's traditionally more expensive than some of the synthetic dielectric fluids, and it can be there's some material safety issues as well with some of those fluorinated systems. So fluids. So there's pros and cons to both, but those are the three different kinds of fluids, and then obviously there's water for the water chilled systems.
Yeah.
Yeah.
So you mentioned it's food grade. Would this be something like I could dip my finger in and put it in my mouth, and like I wouldn't have to go to the hospital and worried about being poisoned or anything like that?
That's absolutely correct.
Wow.
You know, I wouldn't do that with mineral oil.
No, definitely.
You know, mineral oil is really built for machine lubricants and cosmetics and things like that. But this synthetic dielectric fluid is safe. I wouldn't recommend ingesting it, but it is safe. It's not going to cause you any major harm. There's no the material safety data sheets do say that it is safe to ingest. You're not going to need a medical treatment for it. So yes, there's even some people who have on videos, ingested it.
Oh, gosh, no. You're not doing that.
I'm not doing that. I do not recommend it. But again, it is safe. Yes.
Okay, and you also mentioned the viscosity of mineral oil. I know from firsthand experience that mineral oil can be very viscous. And when I first started looking into immersion systems, I mean, this was like 2.5 years ago, and I was seeing Russians putting it in Tupperware containers and, mineral fluid, putting their miners in there. Can you give me a little bit more of an idea of what the viscosity of the dielectric that you recommend to use is?
Yeah, so that is a great question. I don't have the viscosity number off the top of my head, but what I can tell you is that the fluid that I'm using has really good viscosity, low viscosity, even in cold weather temperatures.
Okay.
With mineral oils, you have some waxes and things like that are in the fluid, which cause it to really thicken. And the problem is, as fluid gets more viscous, its heat removal properties are reduced.
Yes.
So the synthetic fluid that I'm using is controlled and built in a way that it doesn't, the viscosity does increase in cold weather slightly, but nowhere near to the point where it becomes unusable for heat removal, and is very similar to water in many respects. And how
so I just kind of wanted like a comparative. Is it like water? Is it like baby oil? Is it like 5W30 that you put into your car? Like, just to get an idea.
The best way to explain it is if you would imagine water with a little bit of almost like baby oil kind of feel to it. It has an oil type feel to it, but it's almost it pours and flows very similar to water. But it does have an oily feel to it.
I have another question too, and I'm sorry to keep bombarding you with these questions. But
no, please.
When you take the cards out, here's another thing that Scott and I see in the industry is, we help broker the sale of miners. And so, obviously if somebody has an immersion system and then they want to repack them, into, just the regular, rig frames and put the fans on or whatnot, how would you get the oil off of the circuit boards itself? Is there a process to that?
Yeah, that's a fantastic question. And that raises one of the pros and cons too of the different types of fluids that are out there. So with the dielectric fluid, it does leave a residue on the equipment, and the providers of these dielectric fluids do provide solvents that are also very safe, that can be used to simply dip and remove that fluid.
Okay.
And when that solvent, when it comes out of the solvent, then it comes out essentially clean and dry.
Oh, wow.
So you can restore that machine back to an air-based system if you needed to.
Yeah, and I've seen some of those before that have come out of immersion, and they look brand spanking new,
Yeah.
sparkly, and like almost
jewels.
Yeah.
Yeah, and with the two-phase, the fluorinated fluids, those do come out dry, because that essentially, the fluorinated fluid is a solvent already. That's what it is. It was, in fact, the fluorinated fluids were designed to be solvents from the get-go. So they come out dry. But with the synthetic dielectric fluids, they do come out with a film on them, and that has to be washed off. But then they come out clean as a whistle, like you said.
All right.
There's an additional process there, though. Yeah.
Okay.
Well, Rob, before we wrap it up, why don't you just tell us a little bit about where we can find you online, and if somebody has questions about immersion, where they could find you?
Yes, absolutely. So before I get to that, I just wanted to mention one more thing real quick. In liquid immersion, you can generally overclock the equipment more than you can in air-cooled systems. And so being able to get 10, 20, 40, 50% more, if not more, out of each machine is a huge advantage for liquid immersion versus air-cooled systems too. So I just wanted to make sure I pointed that out.
Right.
As far as finding me, so you guys are really hearing about the beginnings of my company. I'm just in the startup phase. I do not have much of an online presence, and that's on purpose. But I will be having a website coming up here early in January. I wanted to finish up my testing and the prototype build. I will be offering a joint venture opportunity for anybody who's interested in participating early on, which will have some great benefits and potentially even some equity for folks that might be interested in participating with this company in this new startup. And I'll be having, the Twitter and the Instagram and all the other great social media platforms to go along with it. In the meantime, just feel free to reach out to me directly on Telegram. Is the best way to reach me. I also have a Twitter handle, which is @ContainMint, ContainMint. You can reach me there as well. So I look forward to answering any questions that you have, and really appreciate your time, and really look forward to bringing liquid immersion to the market and helping expand its use across the industry.
Yeah, absolutely. Well, thank you for coming on to our podcast, and we'll talk to you again.
Yeah, thanks a lot, Rob. We really learned a lot and very informative. And I just want to give a shout out to all of our audience. Happy holidays.
Happy holidays.
Yes,
and Happy New Year if we don't see you again.
Take care. Thanks, guys.
Right, thanks. Bye.
All right. And one last time, thank you to our sponsor, novablock.com. And like I said earlier, you go to their website, and on the top right-hand side, click that sign up button. And there's an area for an invitation code, and just type in OFFORD18, and you can get a permanent reduction in your pool fees down to 1.8%. Thank you, NovaBlock.